Cisco Certified Network Associate Day 4. Welcome back everybody, I am Imran Rafai, your trainer for this entire series. Today we are going to learn about internetworking devices. Now when I say internetworking devices, we will be looking at all the devices that is required for your CCNA syllabus. Of course we have many more devices within Cisco, but for your examination perspective, we need to discuss only these 3 devices that we're going to discuss today. We will end today's video with data transmission. We will see how data is transmitted through these devices, right? And of course the videos are going to be very interesting from now onwards, because we would be dealing with real-time scenarios, and we will be getting on to doing hands-on Cisco devices, right? So get excited guys, we are going to have fantastic days ahead. Right, without wasting much time, let's get straight into today's video. The first device I want to discuss today is the hub, right? Let me take a pen. Right, now hub is a device that all of you would have seen in your networking environment. Now most of the people call it a switch. I just don't understand why people call it a switch. It does look like a switch, it has many ports. That's where the similarities end. A hub is a non-intelligent device. Now I say non-intelligent because it does not have any intelligent features in it. It doesn't have a hardware CAM table or a MAC table like a switch has. What basically a hub does is it takes input from one of those ports and it copies that information and sends out in all the ports. So it just acts like a repeater. It has only one collision domain. The collision domain means that if 2 devices connected to 2 of these ports are talking to each other, if the third device tries communicating, all the information, even the communication that's happening between 1 and 2 is also corrupt, and all the devices will have to retransmit. Now there is no way a hub can segregate these 2 communications. So it has only one collision domain. It also has only one broadcast domain. Now what does a broadcast domain mean? Broadcast domain means when a broadcast traffic is received from one port, it will broadcast in all the ports. Now broadcast literally means sending to all the device, right? Now the problem is, if it's like this, the broadcast will not be much. But if, let's say for instance, broadcast is not stopped somewhere, think about these billions and billions of devices that's on the internet. Now if a broadcast happening on my computer is sent to all the computers in this world, and that happens to all the computers in this world, whenever they do any broadcast, it comes to me. Think about what is going to happen to the network. It is going to be a congested, inefficient network. So as the network becomes big, the broadcast traffic will need to be stopped. A hub cannot do that. A hub will take a broadcast traffic, it will just copy it in all the ports. So 3 things that you need to remember about a hub: it's not an intelligent device, it has got only one collision domain, and it has only one broadcast domain. Next we will deal with a switch. Now before we deal with the switch, in between a switch and a hub there is one more device called a bridge. So a bridge is slightly more intelligent than a hub, but not as intelligent as a switch. But if you're just starting in your CCNA, there are 99.9% chance that you will not even see a bridge in your entire life. So don't worry about your bridge, and I don't see bridge in your later CCNA curriculum, so you should not really worry about this the bridge. Now switch is an intelligent device. Now I call it intelligent because it has something called ASIC, which is application specific integrated circuitry. Now what it really means is it has the feature of storing the MAC address information. Now each of these ports are connected to a device, right? Now a switch, within maybe 10 seconds after going up, it will learn all the MAC addresses connected to it. Now how does that help? Now if a device is trying to communicate with another device on a specific MAC address, the switch can send that information only to that particular destination without having to send out broadcast in all the 24 ports of the switch. Now that effectively breaks the collision domain. So unlike a hub, in this case every port can have a communication with another port without colliding with the traffic going from other ports. So literally a switch, if it's a 24 port switch, it has 24 collision domain. That's what a switch is. Now typically assuming that VLAN is not configured, a switch has one broadcast domain. That means any broadcast coming in through one interface, that broadcast traffic will be sent in all the 23 ports. But that is assuming VLAN is not configured. Now you might ask me, what is a VLAN? But you don't need to worry about VLAN for now. We will be dealing with VLAN when we deal with switch in later part of this series. But for now, just assume that a switch has only one broadcast domain. So what you need to remember about a switch is it is intelligent. It has got something called the CAM table, and it has as many collision domain as the number of ports, and it has one broadcast domain. Right. Next we would be dealing with a router. Now router is an intelligent device. Now router has many collision domain. Again, the number of ports it has so many collision domains, and it has many broadcast domain. Now what does that mean? Let's assume that a router receives a broadcast traffic from one of its ports. What it does, it just drops it. It does not forward that in the other port. A router is the border device. Now in one of our early videos when we spoke about subnetting, we told that when a client gets a destination IP address, it compares with itself. Now if the destination IP address is in a different network, it sends that packet or information to the gateway, right? That's what we learned. Now your router is the gateway in most of the cases. So each interface of the router will be connected to a different network. Compare this with a switch. Each interface of the switch should be connected to the same network. But in case of a router, each of these ports in the router will be connected to different networks. Now what does that mean? We will see when we go in the next slides when we discuss the data flow, right? So a router is an intelligent device. It has many collision domain and it has many broadcast domains. Right, let's look at data transmission. Let's assume this guy. Okay, let me just get a highlighter. Let's assume 10.1.1.10 IP address. Let's assume this computer wants to communicate with this computer 10.1.1.11, right? Now if you know the OSI model, we know there are two address concepts, right? We have the IP address, layer 3 addresses, and then we have the layer 2 address called as the MAC address. Now data transmission in the local subnet, or rather data transmission on Ethernet, happens only using MAC addresses, right? So when 10.1.1.10 IP address computer wants to communicate with this computer with 10.1.1.11, the critical information they need is the MAC address. But this guy has only these three information. So it has the source IP address, which is itself. It knows that it needs to go to 10.1.1.11, so it knows the destination IP address. It knows itself, so it knows its MAC address, but it does not know the MAC address of the destination device. What does it do? It uses a protocol called ARP. Now what is an ARP? ARP is Address Resolution Protocol. What it does is it sends the IP address with the ARP request to the switch. Now switch, it's a broadcast. ARP is a broadcast traffic. So the switch takes that ARP request and sends it out in all the ports. So switch gets it here, it sends down that information to all the ports. Now ARP is like calling out your friend's name in a crowd, right? Let's assume you're in a party and you're just calling out your friend's name. Now everybody hears that, but only your friend responds to that, right? So similarly, when this information is received by everybody except for this computer, 10.1.1.11 computer, everybody else just drops that packet. But this guy, what it does is it says, okay, this is an ARP for me. whoever sent this to me needs my MAC address. So it put its MAC address in that, and it sends a reply. Now the switch gets that MAC address reply, ARP reply, and it knows that this ARP came from 10.1.1.10. So it sends that reply back to 10.1.1.10. He gets that information. He says, fantastic. He now has all the information to send the packet. So he's got the destination IP address, source MAC address, destination MAC address. Now it creates a packet with this information, gives it to the switch. Now switch looks at the layer 2 information, because switch works in layer 2. Switch can only look at layer 2 information. So it looks at the layer 2 information. It says, okay, it has to go to MAC address of 2222. Now, like I said, a switch has intelligence. Now what does intelligence mean? Intelligence meant that in the 20 seconds after the switch has come up, switch would have learned all the MAC addresses. So it would know which port which MAC address is in. So now the switch knows that the MAC address 2.2.2 is connected to this port. So switch forwards that packet only in this port, and this computer receives that packet. So the minute it receives that packet, it strips the layer 2 information and it looks at layer 3 information, and it realizes that packet was destined to him, and he accepts that packet, and the transmission is complete. Now this is a local transmission. Let's look at what happens if it has to go out of the network, if the destination IP address is not in the same network. Alright, in this case we will look at a scenario where the 10.1.1.10 IP address wants to communicate with 30.1.1.1. Now in both these cases we are assuming one thing, which I forgot to tell in the last slide, that the subnet mask is /24. So it is 255.255.255.0, right? So now this guy wants to communicate with 30.1.1.1. In this slide we will be not looking at ARP. ARP exactly works like how it happened the previous time. So when this computer looks at the destination IP address, it realizes 30.1.1.1 is not part of 10.1.1.10 network, so it's not in this network. So if the destination IP address is not in the same network, it has to forward that packet to the gateway, right? So if it's a Windows computer, when we configure the IP address, we also configure the default gateway, right? So it knows that the default gateway is 10.1.1.255. Now if it knows the MAC address, it creates a packet. But if it does not know the MAC address, the same ARP request is sent again, and it's sent to everybody. This router will respond with its MAC address, which is AAAA, and then it will create the packet. So we will not go through that, because I'm assuming that since we did it in the last slide, I'm assuming that you know the working of an ARP, right? So let's assume all that is done. So it knows the MAC address, destination MAC address, so it sends that packet to the switch. Now switch knows where AAA is, so it sends out that packet to the router. Now the router gets that information, and router, as you know, works on layer 3, right? So the minute it gets that packet, it strips down layer 2, it looks at layer 3. Now it says that layer 3 destination IP address for this packet is 30.1.1.1, but it looks at both its interfaces, and it sees that, okay, 30.1.1 is not connected to himself. Then it looks at the routing table. Now we have not done routing so far, so we don't know how routing works, but just to understand how routing works, routing is where devices communicate with each other. Now in this case, this router, since he's connected to the 30.1.1. network, he would have told him that if you get any packet for 30.1.1.1, please forward it to me. Using that information, this router would have updated its routing table, right? Don't worry too much if you don't understand the routing concepts, because we will be dealing in depth in routing and routing protocols and all those things in the next video or the next subsequent videos. But for now, just know that this router knows that 30.1.1.route is through this router, so it needs to send that packet to this router. So what it does, it updates the source information. The source MAC address is himself, and the destination MAC address is this router. Now that packet comes to this router. Now this router takes that again, strips the layer 2 information, looks at the layer 3 information. Destination IP address is 30.1.1.1, and this router looks at itself and it sees that 30.1.1.0 network is directly connected to it. So what it does, it updates the layer 2 information, that is the source MAC address is DDD and the destination MAC address is 444. Remember, it has two MAC addresses. The source MAC address is the port through which it is sending the data, right? It is not the receiving. So in this case, normally that's how you get confused. Each of these port has its own MAC addresses. The source MAC addresses would be of the port through which it goes out, right? So in this case, this information is updated and this packet reaches the file server. The file server strips the layer 2 information, looks at layer 3 information. It sees, that is addressed to me, and it receives the data. It goes to layer 4, layer 5, layer 6, layer 7, reconstructs the data, and it gets back the original message. Now this is how data transmission happens over the network. So these are the three critical devices that you need as a CCNA, and I hope you understood whatever we discussed today. Now you know the drill. If you do have any question regarding today's video, please feel free to write into me at imran.rafai@nwking.org, or you could also leave comments below this video section on YouTube, and I will try and answer it as soon as possible. Thank you so much. Keep watching and happy learning. Bye bye.